Thanks, Alex, and good morning, ladies and gents. I do have the unenviable task of trying to convince you, and it's not going to be easy, I know. Just like you, I'm also a skeptic, and when we started getting weather data from the BOM, it always interested me to know how accurate was our weather data. So maybe just a bit of background before we jump into the actual accuracies of the weather data. So in ASKBILL, we've got a really extensive weather data set. So for each, we've got weather data on a 5 by 5 kilometer grid scale for the whole of Australia, and that also includes the major offshore islands around Australia. So that's about 278,000 grid points that we keep data for, and for each of those, we've got 32 years worth of historic data. We stream in current observations, but also short-term and long-term forecasts. So on a busy day, we process up to 1.4 billion forecast records. Very importantly, when you register your property on ASKBILL, the system will then identify the closest grid point to your property and use that personalized weather data for any predictions being done. Currently, we source all of our data from the Bureau of Meteorology, but that doesn't prevent us from investigating other sources as well. So we firmly believe that BOM is not going to be the only answer to our weather data in the longer term, and that there will be other models out there and other sources of weather data that could be more accurate and more suitable for certain times of year, for certain areas of the country. So shown here is the rainfall parameters we ingest and keep. So from 1 January 1986, we've got, for all of those grid points, we've got historic data until yesterday, and that is mainly sourced from the AWAP weather feed. Then we've got ADFD, Axis R, and Axis G data that provides us with our short-term or deterministic 5-day forecast, and we've got Axis S data that provides us with that longer-term forecast. So for Axis S, we get 11 of these forecasts per day for each grid point. So that makes for a large amount of data that needs to be processed and stored on a regular basis. So just shown here is the spread of the weather data we're working with. The reason why I've included this slide is that to show you that for each time that you run a model in ASKBILL, we actually run that model 30 times. We start with the historic data, and that is that green area on the graph. Then we move over to the probabilistic forecast, and that spaghetti, colorful spaghetti going into the future, is the probability of the rainfall. So this is a chart of the cumulative rainfall for a property that's already registered in ASKBILL. We've decided to monitor fairly intensely across 20 monitor points across Australia to see how accurate the weather data is. So because the volume of data we work with is so vast, we can't do any more. So we had an option to either do a fairly shallow take and just do a measurement for a lot of weather stations once a month or once every 3 months, or alternatively, take 20 weather stations and monitor those fairly intensely. The reason why we've chosen these particular weather stations is they are, some of them have been used in the information nucleus flock, and they also fairly close to calibrated weather stations where we can get actual weather observations to compare all the forecasts and interpolated data against. So the first issue I would like to address is the 5 by 5 kilometer grid accuracy. So because there can't possibly a weather station be at every 5 kilometers, that data set is basically interpolated. So there's a supercomputer that scaled down the actual observations on a daily basis, and that gets ingested into our database. Shown here is, on the right-hand side, is the relationship between the interpolated and the observed weather data. And as you can see, some instances, it doesn't pick up, for instance, thunderstorm activity. So you would get an intense thunderstorm that's very localized, and that doesn't get picked up by the model. And to mitigate for that, we've built a facility into ASKBILL where you can override the rainfall for both the property as well as on a pasture level. And the adjusted rainfall is then used in the forecast going forward. But overall, tracking for 2 sites in the southern end of Western Australia, you can see the total rainfall tracks fairly well. It's very important to get this bit right because the pasture growth over the next 2 to 4 weeks is really dependent on the rainfall that's just fell onto your property, and as a result, drive the soil moisture that's available in ASKBILL. So looking at the short-term forecast, and this is really important for worm risk, fly risk, but also heat and cold risks that we issue on a daily basis. So our deterministic forecast is a 5-day forecast where we've got a lot of certainty around what the weather will do. And so our chart on the left-hand side, we are looking at what is the standard deviation of error between our minimum and maximum temperatures. So the blue line is our minimum temperature. And as you can see, we'd be out by about 2.5 degrees after a day, and that rises to about 3 degrees forecast 5 days out. But our maximum temperature is a whole lot more accurate. So maximum temperature at a 5-day period is out by 2 degrees. So that's fairly accurate and accurate enough to do short-term risk forecast for heat and cold. And we can also determine if worms are going to be killed off by that. And even the temperature our minimum temperature is not perfect. There's also a very strong correlation, but there are instances where some of the important events are missed and misrepresented. Then looking at the chance of rainfall, and I know this is one of the more interesting slides that I'm putting up. So if we predict rainfall for the next day, there's a 75% chance that will eventuate. And even out to 5 days, we get a 55% chance that we will actually get a rainfall event on your property. Looking at the error for that particular event, it's fairly small. In terms of rainfall, we're talking about between 6 and 8 millimeters from day 1 to day 5. So it's not significant amounts of rainfall that is going to be missed. The most difficult to visualize and to measure is the accuracy of the long-term or that probabilistic spread and forecast. And so time prevents me today, as well as a fairly strict master of ceremonies. So I can only give you a fairly brief overview of what we do. So what we've done here is on a daily basis for a month, we measured the forecast, and that's that green line. And so in the box, and for this box and whisker split plot, we've got the 25th percentile over there, we've got a 50th percentile over there, and the 75th percentile of the forecast for each day of that month. We also show the outliers in the 5 and the 95 percentiles. And the red lines, or the red bars, are the actual observations. So the reason why I've put up this plot of Bernie in July is to show you when ASKBILL don't get it right, it gets it almost right, and when it's spot on. So my next slide, I've prepared a rolling presentation of Trangie in New South Wales, showing you a typical spread of how accurate the long-term forecasts are. And as you can see, it's not perfect, but it's fairly well spot on. What's also important is the number of rainfall days. And so shown here is the number of rainfall days spread across for all of the major sheep growing areas, because it's no use if all the rain falls within 1 day. So getting the number of rainfall days right, and there's a very strong correlation between what is predicted and what was actually measured from April to November 2018. So everyone would be interested in how well we've predicted the drought. So the orange line is the climatology. Green or grey is what ASKBILL predicted, and blue is what actually happened. And so you can see we actually predicted a fairly dry year than normal from last year. So thanks, ladies and gents. We recognize that the weather forecasts aren't perfect, but we didn't expect it to be. So is it good enough to make productive decisions with that? We certainly think so. But we will also be working with BOM to give them this feedback and help them to improve their models over time. Thank you.
Thanks, Johan.